Good afternoon, or good morning, good evening, wherever you are in the world. Great to have you with us. Welcome to SurrealDB stream number 28. It's been a bit of a while since we had our last stream now, but excited to be with you today. Joined by Emmanuel here. We're going to be looking at indexing in SurrealDB, specifically at traditional indexing, full text search indexing, and we're going to be touching on how this has been implemented in SurrealDB and how the way it's been implemented enables us to be used and be run as an embedded database, a single node database, and then all up to a distributed database, which scales linearly. So, Emmanuel, welcome. Great to have you here. For those of you who haven't met Emmanuel before, he's been on a number of our streams in the past. Emmanuel is focused almost entirely on the indexing engine and the core engine in SurrealDB, specifically around traditional full text search and also vector search, which is definitely interesting to a lot of our users out there at the moment. So, Emmanuel, welcome.
Thank you, Tobie. Yeah, it's a broad topic, right? There is a lot to say. So, and I think we are going to do that a little bit interactive and see you and going to the topic that you guys want to see. But last year, one of the first main thing that was added in the product was full text search, which was a main evolution, and we are going to talk in details about its implementation. And indexing was already present, right? But not yet always used, depending of the way you would build the query. So there were a second big feature that came out last year, which was the query planner. So the idea with the query planner is to understand what the query is doing and trying to make an execution plan so we can execute the query as fast as possible. Before the query planner, as a key value store behind the database, we would iterate over every row and then make all the assertion or whatever. But we would indeed iterate what we call usually a table full scan, right? And of course, the graph queries would be more optimized, and you have also the option to make range queries. So there is many way of using SurrealDB in a really optimized way. But once you go to a complex query on a table, then you would go to a table full scan. So the mix of indexes, whatever they are, by the way, full text or standard indexes, and the query planner bring the opportunity to have an execution plan that then would try to use the index in avoiding going to the table full scan. So this is a complex topic because the richness of SurrealDB, the language that you like, and all those functions that are available, all those capabilities between graph, range queries, bring together, give our time to the query planner. And it's a beginning of the query planner, and it's going to be improved. So actually, we have two main strategies that have been implemented in the query planner. And what I would like to do today is to briefly explain how it works. And because SurrealDB is a tool for developers, right? You are building applications, and the way you are designing your data and the types you are deciding to choose, the fact that you are creating an index or not will have an impact. And the tools that we provide can try to be as smart as possible, but they will never be as smart as you are when you are designing your application. And so this is what I wanted to showcase today and show you the tools that we have exposed last year. And that make progress. Every new release comes with some improvement there. That usually comes from feedback that you are doing, and yeah. So if you want to be, I would like to show this to make a quick demo on this thing, and yeah.
Definitely sounds great. Before you jump into Surrealist there, we'll also be looking towards the end of the stream at what functionality and features and query operators are supported in that query planner that Emmanuel just mentioned, and also the things that we're working on at the moment and the other things that we've got planned in the future. So if you're interested in some of your queries, how we can improve the performance around that, we'll probably be touching that towards the end of the stream and looking at some of the things we'll be improving on and building upon. Otherwise, if you're interested in seeing how it works, seeing how it's implemented, Emmanuel, take it away.
Okay, thank you. So let's go for it. So let's make a quick a quick. Everybody knows Surrealist here, right? So if you haven't tried Surrealist, I mean, you should really go because this is really an amazing tool. So let's create.
Let me just jump in for the people who haven't heard of Surrealist yet. So Surrealist is the user interface that you can use to completely manage every aspect of your database, your instances, your cloud instances if you're in SurrealDB Cloud as well. And if you're not in SurrealDB Cloud, you should definitely check it out. You can spin up a free instance and check it out yourself. But Surrealist enables you to visualize your schema, visualize your tables, run queries, edit and visualize GraphQL as well, upload and define functions. It's very fully featured. It also has automated documentation generated based on your team tables and your schema. So if you haven't used Surrealist, you can use it in the web app, surrealist.app, or you can also download it as a desktop application. And really, it's the most easy way of getting going with SurrealDB.
Okay, thank you, Tobie. So we are in. I just have created this body table that contains some planet, some satellites, and the black hole. No, I didn't put the black hole. We're good. So we have three fields. It's a pretty simple table, right? So I call them body, and they have a name, they have a type, and they have a system. So usually, if you don't have any index and you do a simple query, here we go. Let's search for planet. I'm adding my query here. Okay, after it will be faster. I use create, which is my last. So here I have my. Let's put the name there. So it's a little bit more nice to see. Okay, here we go. So here I have my list of planet. I think I have created too much of them. Here we go. I have some duplicate because I didn't use the name as a key. Okay, here we go. Here we are. So when we do that, we iterate over the whole record, doing a table full scan, right? So if I do an explain here, so for the one that didn't know explain gives you an explanation about what is going on. And what we see here is that we are iterating the table, which means we are going to every row individually, and we get the record, and we are going to check if planet is in the tag file. So if I create an index on type, I have, so let's do that now. Creating an index is pretty simple. If I do that, I now have, let's query, an explain plain that explains that I'm using an index to iterate. The name of the index that can be used, in this case, we had only one, the operator used, and the term that was looking for. So what we understand from there is that now we have iterated over only 4 records, right? So of course it's going faster. And if I even add another clause in my condition, like system or even name, whatever, I'm still using my index, right? So I'm still iterating over my index. So I can make a pretty complex query. So this is what we call the end strategy. The end strategy is handy because we can decide, even if we have 2 indexes, we can decide to use either an index on type or index on name. Because we are using an end, it's intersection of the result. So we are comfortable. So this is what the query planner is doing. When the query planner is seeing this query, it understands that he has an index on type, and then he will decide to use the index there. Right? You may have a situation where you have 2 indexes. So let's create a second index. In this case, in name. And then we understand that we have the options to take either one or the other. In this case, the query planner has decided to use now the name and not anymore the type. So this is all good, with one limit. One limit is that we understand that if I search on the name, we understand that we are going to retrieve only one record, right? Because we know that the name is unique most of the time. If I would iterate on the planet, then I will iterate on more. So this is an example of thing where currently we don't have information. The query planner does not know if the cardinality of the type is bigger or smaller than the name. You know, because you know the typology of your data, right? So in some system, you may compute a statistic. So this is an example of things we are thinking about where the index could try to compute the cardinality and have more information and then help the query planner to decide which index is more interesting to choose. But this comes with a cost, right? And in the way we implement things, usually we have to make some trade-off, deciding of do we compute statistic, which would mean that each time you are adding a new record, we may have to update more information, and we will slow down ingesting records. So this is the kind of trade-off that usually which we are happy to have feedback from you guys about what you think about what could be an interesting trade-off. And sometimes we made things more optional, so you can decide to use them or not. And when we talk about executors, there is some parameters that we use about pagination, about size of batches that exist and that may speed up your query depending of the quality of your data, right? So yeah.
I think it might be good to jump in there and just touch on two things. So the first thing is, why does it use name and not type when we've got two defined? Is that because it's alphabetical?
Or it may be. There is no rationale, but there is iterations, right? The code. If you look in the code, there is something called plan and plan builder in the code of SurrealDB. You will see that there is some trade-off because there is many options, right? We can have compound index. If you have a compound index and that the first and so if you have a compound index on type and name, we will preferably go to the compound index. And then if we have two indexes that are the same kind, then it's absolutely random. I mean, it's not random. It's probably a hash issue because we are probably storing the index in a hash table, and so I cannot tell you which one would be selected. But then if I want to force something, then we can do with index, right? And if I do that, then I can say, look, if you have to use an index, with index. Then please use index type. And then we are saying to the query planner, use this one. And then we have a chance to operate faster because we know the quality of our data, right?
So the second point is to touch a bit more on that point that you've made about, everything in a database is a design decision, because ultimately if you optimize for writes, you may decrease the performance of reads. If you optimize for reads, you can decrease the performance of writes. So incredibly importantly in SurrealDB, you have to think, because of the way it can be deployed in many different ways, you have to think, how does a particular piece of functionality affect an embedded database, a single node database? And that's very easily comparable with lots of other systems out there. But then also that same functionality, how do you make that work when you're running in distributed setups with multiple nodes, multiple compute nodes, and you may be writing lots of records per second? If you, for instance, want to optimize for knowing the total count of a table or knowing the total count of the records in that index which are planet, so storing 3 in that index for planet, we then have to have a single point of contention where we're updating a record potentially when a record does equal planet, and that doesn't necessarily scale for distributed environments. So every single thing that we build into SurrealDB has to be thought of in terms of the overall architecture with regards to embedded, single node, and distributed environments. And that is why certain things in SurrealDB can be easy and very obvious, and some things may be a little bit harder and take a little bit longer to build in.
Absolutely. And I will not spend too much time in making demonstration, but I will just do another one, which is when you are changing the condition, then there you are changing the way the query planner may evaluate the possibility. And is pretty nice because it's an intersection, right? Each clause or part of the condition is going to restrict the result set. So it's pretty comfy, and query planner like that. But once you are using OR, then you are literally saying, look, I want a body if it is a planet or if the name is sun. And I will give another example. I will use system there. And you will understand what I mean. So when we do that, the query planner can be an enemy because let's create quickly, and it will be my last demo after we can go in anything else. But if you create, so let's create a new index, right? So now I created an index on system, and I'm saying I want either a type planet or something that belongs to the system solar system. So if we look at the explain plan, which is this one, so we see that there is 2 iterations. And I would say really use explain, right? Because we in the future, and we continue to improve that all the time, we will add more and more information in explain plan so you understand what is going on and you can then take decisions, right? So please use explain. In this case, we are doing 2 iterations. We are doing a first iteration on the type. So we are using an index type on planet, which is then returning 1, 2, 3, 4 records, right? And we have a total of 7 records. So we just
I
retrieve.
missed that 4th planet. I missed that earlier. There you go.
Okay, so we just iterate on 4 planets because of this condition, type equal planet. But now we have this other condition, which is system equal solar system, and solar system is 1, 2, 3, 4, 5, 6 records, and this is what the second part of the plan is doing. So we are iterating over 10 records. Rather than iterating over 7 records. In this case, it would have been more interesting to do, because it's another option that you have, to do with, it's with no index, because then we will iterate only over 7 records. So the query planner can be handy, can be useful, but depending of the query you are doing, the complexity of the query you are doing, sometimes it can be a really enemy, right? So the typology of your data, you know what you are doing, you know what is the semantic of your field, what is the cardinality of your field. So please be aware that we try to be as magical as possible, but there is some limits, and we can make silly things, right? I mean, we can have silly decisions. We will try to do that better and better, but still we can make some wrong decisions. So please explain your queries, have a look. There is many optimization. We now do also, we have indexes like that works like joins on the record IDs. So if you make a join on 2 tables, we are able to use indexes if they are existing. So this is a big improvement. We in 2.2 we are also including now, or maybe we can start talk about this after. But we are handling much better start and limit. So if you add start and limit rather than putting the whole result set in memory and then ordering it, we maintain a priority queue. So there is many improvement that comes all the time. And usually explain will provide information about the strategy that has been used. So yeah. So yeah. This is my demo.
That leads us to touch on a few of the things that you mentioned today. And I think the first thing is you talk about iterating over a table, but what does that mean in SurrealDB's sense? Because the way we've implemented the core engine and the storage engine in SurrealDB, and the ability to swap out storage engines, for instance, RocksDB with SurrealKV, and we can touch on that a little bit more as well, can lead to certain optimizations. But I think it's also interesting for our viewers today and in the future to know what we mean by iterating over a table. So in SurrealDB, you have tables, you have effectively collections if you're coming from a document database. But there is no concept of tables in the storage engine and how we store data. Effectively, we store data in a very, very big list. And that list is effectively ordered. So when we store an element in a table, it is defined by a particular index key, and that index key gets inserted into a list. And when we talk about iterating over a table or iterating over an index or processing these queries, effectively we're going into this very big list, and we are either getting a single record or we're iterating through a number of records and then pulling them out and processing them. And that is what enables us to switch storage engines to SurrealKV or TyKV, and in the future other storage engines that we're working on and will be supporting. And it's probably worth mentioning why we're building SurrealKV and optimizations that will potentially give us. So for instance, looking at your example today where you said, it would be great to know how many planets exist in that index. And we know by looking at your query that there are 4. But the indexer doesn't know that. There could be millions, there could be 3. And it doesn't. The planner doesn't know that until it's iterated through them. And by building our own key value store, we can then build in optimizations, which enable us to say, underneath this prefix, how many nodes are there? Instead of forcing us to iterate over them from an external API point of view, we can actually do that internally within the tree structure. And that would enable us to perform better optimizations. Emmanuel, I don't know if you had any other insights for users in terms of how we are implementing these indexes, because I know traditional indexes like the one you demonstrated there are simple almost to explain and to develop. I say simple. Apologies for that. Emmanuel spent many long hours on implementing these storage techniques and indexing techniques in SurrealDB. But what I would say is full text search is a different beast unto itself, right? And the complexity around that and how it operates and how it groups things into blocks. Explain to our viewers a little bit about the differences between traditional indexes and then full text search and vector search and how that's implemented on top of our storage engines.
Yeah, it's interesting because you said about you compare complexity and simplicity. So the index that you have done initially, which is a standard index, this index is much more powerful. I mean, as interesting in the sense that each record, each item is a different item, right? So which means that we can have parallelism that does not exist. That is actually an issue with full text search. So full text search is a complex topic because when you put a text and we want to index it, it's not just one value associated in one record. In fact, we tokenize the text in different in a vocabulary, right? And this vocabulary is then attached to the record ID. So of course, terms like a, the, in, of, those terms are out of the sudden attached to thousands of records. I mean, depending on the size, of course, of your data set. But so there is this dictionary that has to be built, which is shared across the whole index. Which is already a limitation that the standard index does not have. The limitation actually on the full text search index, and we will come up with a new implementation that will provide different capabilities, and it will be interesting to compare. The current full text search implementation is single writer. It means that you cannot update in parallel different records. So because the dictionary itself, it's a single point of contention. So this is something that it was a design decision due to the fact that it's also an optimization where we store currently the dictionary as a B tree. So there's a B tree implementation where the dictionary is stored. And of course, when you update a document, then we may update the same page of this B tree, which is the reason why it's single writer. We are currently working on a new implementation where we will not have any more this single point of contention, which will allow to index faster, with the price of having more record stored. So because, as you said, table does not exist in SurrealDB, right? Behind the scene, we are using a key value store, and we use the keys, and we are building what we call prefix keys, where the namespace is part of the key, then the database is the name part of the key, which works really well because when we want to locate a record, it's absolutely fast because the key value store store the keys in an ordered way. So it's absolutely not an issue. It's absolutely powerful and fast. We don't have any benefit in organizing things differently. But when it's about the full text indexing, then we have these nodes that are shared across the dictionary, and then we cannot write them simultaneously. We have to write it in a serialized way, right? So in the next upcoming implementation, we are going to have separation. The dictionary is going to not anymore be in a B tree, but we will really use different entity record. So it means that we will multiply the number of records. We will have much more records stored in our key value store, but then it will allow for a parallel ingesting, and also it will probably go faster in terms of. So it's always a trade-off, right? So the idea that we have is not to decide of one specific implementation, but rather providing different implementation that will fit well in different situations. So it will be the case for full text search. So full text search will come probably with 3.0 with a new implementation that will be better, provide better concurrency and better parallelism. It's true also for HNSW. We have vector search capabilities, right? So you have seen M3. M3 has the same issue because it's an issue. It's both powerful and both an issue. It's using a bit tree for storing the node. But we are soon going to have an HNSW implementation that will also use parallelism. So which will be a little bit more consuming in terms of storage, but faster and providing better parallelism capabilities. So yeah, so we are going to, I would say stay tuned because we are going to provide new implementation with different capabilities, and we will try to explain those capabilities so you can make your decision of which implementation fit better for you.
Yeah, definitely. While we're on that topic of kind of future changes, so as Emmanuel said, we're rewriting the full text search implementation, and we're improving the vector search implementation. So these will be better performance, the ability to handle concurrent writes, concurrent workflows. That's incredibly important in a distributed setting. So if you are running SurrealDB with multiple compute nodes, you're going to have fewer transaction errors, which are conflicts effectively, where it tells you to retry the transaction. Things are going to work better. They're going to work more predictably. We're also working on support of additional operators, additional query types. Emmanuel, talk a little bit about that and also the support around the ordering that we're working on at the moment.
Yeah. So the operator, so the ability to use the indexes was initially based only with the equal operator, right? So you should have to use equal. Compound index was also not able to work with different fields. So you would use compound index for unicity, but we will not use them on the query planner. So with the few improvement there is now we handle really well contains as an example. So we have equal, contains, of course, the search operator and TNN. There is different options. So, but contains was the main thing. Compounds have been improved massively. So now, if you have a compound index and you search on the first field or all the fields of this index, we use it and we use it to speed up the query. Be careful with compound index. If you have field 1, field 2, field 3, and you search for field 2, we cannot use the index, right? We need to go from, we need to respect the order of the indexing. So if you have field 1, field 2, you can use the index you use for field 1 and field 2, field 1 and field 2 and field 3, but not field 1 and field 3 as an example. That does not work as well. So yeah.
How you write your select statements, how you write your queries is definitely important. And remember to use the explain clause at the end of your select statement all the time to measure that.
Yeah, absolutely. So then about ordering, we work on order. There were some questions. The community asked a few months ago saying, guys, you have indexes, but it seems that order by is not using it. And you were right. So it was not yet the case. So now it's the case. So when you use order by ascending with an index on an index field, now we are using the index, and so we don't need any more to store the result set in memory, then sort it, and then only streaming out. In fact, now we are directly getting the order keys by the index, and we don't do the sorting anymore. So this is faster. And also consuming less memory. If you use, so I said ascending because it's not yet descending.
Yeah.
Well, it's coming. So it's coming. Also, if you do order by ID, we don't use the index anymore. I mean, it's silly, right? And so it will be fixed because when you do order by ID, it's like doing no order at all because then we provide the result order by ID. If I'm not wrong, maybe there is a
Yeah.
situation where it's not the case.
So just to explain to the community and the users, everything in SurrealDB is ordered by the ID naturally. So all of our IDs are stored ordered. If you insert 55 random records into a table, they will be ordered by their ID in an ascending alphabetical way or alphanumerical way. So when you do order by ID, currently the query planner doesn't actually realize that that's the case, and it actually kind of reverts back to doing a full table scan and having to sort those records, whereas actually they are already sorted. So these are definitely improvements that we're making, as Emmanuel said, and order by descending is something that's coming very soon. I think a few other ones that always gets users coming to SurrealDB, and something we're working on and hope to be having soon, is support of the entire query planner in update statements, delete statements, and things like that. So you can very easily optimize those queries using a delete from and then a subquery. There's no issue with that, and the subquery itself as a select statement will use the indexes. So that really doesn't add that much overhead at all. Same thing with update, but we'll be actually adding support for the query planner very soon in a future release, and that will enable you to write your update statement normally, and it'll only select those records based on any indexes that are defined before updating them. So that's going to be a massive improvement to the usability of SurrealDB, along with support for additional operators, additional directions of ordering. So lots planned and lots coming. Emmanuel, anything we've missed?
Yeah, start and limit, we talked quickly before. So when you use start, order by, and start and limit, what we did it before, we put the whole result set in memory, and then we strip the result set, right? Which is memory consuming, of course. So what we have now, if start and limit is less than 1,000, less or equal to less 1,000, then we use what we call a priority list. A priority list is just a result set that maintains the things in order, but does not store the whole result set. Just receive a new record and decide and put its order in the list, and the list does not grow over the size of the pagination you have chosen. It's usually faster because it's most of the time you will not make paging of 1,000. If you do a paging of 10, it's much faster to insert ordered in a list of 10 than maintaining. Even if we use, we can use really efficient sorting strategy for a whole result set, but still it will be faster if the priority list is slow. So we have this priority list that probably, if you use pagination, you will see some improvements. So this comes with 2.2. But depending, of course, on the size of your record, the size of the order by, the size of the content, and this is something I would like to also to put the emphasis on. We have a few configuration parameters that you should be aware of. And so this 1,000 is one of them. This 1,000, which is what we think a good value. But of course, if you're ordering on 6 or 10 fields, maybe it's not the same thing. If your fields are a string of 1,000 characters, not the same thing. It's just a small integer. So of course there is different situations. So this 1,000, which is a value that can be modified with an environment variable, and there is few of them. So and most of the time it's well described on the documentation. So please have a look at the documentation on configuration parameters, because you may discover some optimization that we expose and that can really make a difference in your experience.
That's amazing. I'm just going to jump in, and there's some questions from the communities. We're going to jump in and answer as many of those as we can. First up, Yasser, thank you for that. SurrealDB is the only DB you need in a simple world. I would say it's the only DB you need in any world. What we're trying to build at SurrealDB here gives you the performance and the power to build your applications, but also to be able to manage multi-modality of data or multi-model data. So whether that's graph, document, time series, traditional tabular data as well, geospatial as well. That's another index type that we hope to have in the future. So definitely, we love the fact that you love it and said that comment. But we're always improving. We always want to build in more useful stuff so that it makes building applications even easier. So thanks for that. just looking through here. So
Oh, I
another,
wanted. Oh, sorry.
yeah,
While you are searching for a question, I also would say that Discord is there, right? And we know that everything may not be documented, even if we make progress all the time, and documentation is better and better. There is things that you may see, especially if you are using the nightly release, if you want to try earlier on some features, or once a new release comes, usually documentation is up to date, but we may miss something, right? And so I have a look at the pull request, because most of the time we put the rationale of what has been done on the pull request. And Tobie is known for making a really nice description where you can really go in details, and there is more detail that you would like probably. But look at the pull request, and then also Discord. I mean, we like Discord. We like the community there. You are more and more, but we are really happy to jump in and answer questions, and it's also give us feedback. In my case, it's a place where I can really build the roadmap related to indexing, and so please don't hesitate to ask questions there if you have doubt, because we are happy to just interact.
definitely. Just to add to that, we've got GitHub, we've got our GitHub issues, and you can look through the pull requests. Discord is a big one. It's a vibrant community. If you're not on our Discord, you can chat with members of the team. You can chat with people who can support you and help you on your questions. But also, there's a great number of developers out there who are building, developing, hacking with SurrealDB, and they're constantly online. So if you haven't joined our Discord yet, then definitely jump in there and take a look and share what you're working on, ask some questions, and everyone will be happy to help. So yes, another question from Yasser is, how about time series index? Now, in SurrealDB, there are a couple of ways of going about indexing and querying on time. So you have the traditional indexing that or standard indexing that Emmanuel talked about, which is effectively you can say, I want to index on a field which is a time field, and that will enable you to search on that time field later on, and that's fine. There's another way that you can actually do this in SurrealDB, which is almost, I think, unique to SurrealDB, which is being able to store the time as an element of the record ID key. So, for instance, your record ID is traditionally an integer. So that's the ID of your table record. So 1, 2, 3, 4, 5. Now, you may want to increase that and make them UUIDs or random IDs so that they're not kind of increasing over time as records are created. So then you can use randomly generated IDs or UUIDs. You can then go a step further and you can say, I want my record ID and the ID of my record in the table to be an array. And the array can be two elements. This first element may be the date time that this record was created. The second element may be a randomly generated ID or potentially a city. And then the third element, if you want to have a third element, could be a randomly generated ID as well. Now, there's no limit to how many elements you can have in that ID. What you can then do is you can actually say, look, I just want to select from this record to that record. And without having to use any index at all, you're able to jump straight to that part in the table without indexes on the table as a whole and without any overhead or performance implications. In addition to that, we're not going to have to iterate over 5,000 records before we get to that record that you're starting from. It starts immediately from the record and it will stream and scan through to the record that you're ending with if you choose to put an ending point. So we can talk about that more in a future stream. Effectively, that is, there's a blog, if you're on YouTube, we've just shared a link to the time series blog and how to do time series indexing. But those are called in SurrealDB complex record IDs. So look in our documentation for complex record IDs. They support arrays or objects. Arrays are much more easy to work with than objects, but you can use both as a developer, as an engineer. And it's a really interesting way of modeling time-based data and time series-based data in SurrealDB. So definitely check that out, and we'll do another stream on that in the future because it's such a powerful feature that a lot of people don't necessarily know about.
And if you allow me, I just want to, well, you were talking about ID, right? ID can be really complex, can even be an object if you want. And in 2.2, we come with an optimization. So we were talking about executor and the way we scan the records. So something new that comes with 2.2 is if you are just interacting with the ID. So now we are iterating only the keys and not anymore the key and the record, which is an optimization, and it's visible on the explain plan. If you look at, so it's not anymore the table iterator. I think we call that table case iterator, if I'm not wrong.
And range.
And range, right? So absolutely. So this comes with 2.2 and will probably speed up many queries that you guys are doing.
Yeah, absolutely. So just to summarize, so you could support many types of indexes and let the user select the type of index based on the need, as in Postgres. That's exactly what you can do in SurrealDB. So right now we support standard indexes, unique standard indexes. So that's the ability to mark something as unique if a value already exists in the index. We support full text search indexes. There are lots and lots of different ways of customizing that depending on how you want to tokenize the text, how you want to remove or kind of standardize the words being indexed inside text. And then we've got two types of vector indexes right now. We've got, remind me, Emmanuel, we've got M-tree and we've got HNSW. That's it, isn't it?
Yeah.
And then, we want to support more types of indexes as long as they can be supported on the different ways that you can run SurrealDB. GeoJSON definitely in the future, and more index types as well. But as already you can index a lot of pretty much all of your data types in SurrealDB using those different index types. Chase, we've got a question here. Thanks for your question. What if you could put in the index definition some sort of automatic cardinality calculation or manual via some sort of SurrealQL syntax like type? I'm not sure exactly what you mean by that, so if you could clarify that. But Emmanuel, if you understand the question,
I think we could. The index itself could maybe store some cardinality information. So we are thinking about this. So because in this case the query planner could take decision depending of the value itself, right? We could embed. So yeah. So please do some input. I mean, feel free to do feature requests where if you have some ideas about feature that you like on other database and that you want to see with SurrealDB, it would be indeed interesting to have this kind of discussion. So it can be on Discord as well, but it can be a feature request if you have an idea of what it could be. I mean, and if we don't want to implement it, we will let you know. But most of the time, we are keen to get your input. So cardinality calculation is doable for some indexes, or we could have some indexes that optionally could do some cardinality calculation. So you will probably pay a price on insertion and deletion, but then you would have something that an index that will be more efficient. So it's typically the kind of things we want to do, rather to have something that automatically decide for you. It's more interesting for us that you decide about an implementation that will perform better because the quality of your data.
Awesome, Chase. Thanks for that question. And yeah, definitely jump into our GitHub issues and add a feature request for that. Describe it as best as you can, because that always helps us when we're building in new functionality or fixing issues. So there you go. We've shared on the bottom of the screen there where you can go to submit ideas and feature requests. Question here from Francisco. Great to have you here with us. Any plans to build an explain UI visualizer in Surrealist? Definitely. We want to. Surrealist is a great tool for working with SurrealDB and with Surreal Cloud, and we're constantly improving it. We've got some exciting new features and new functionality being released very soon. So we don't have a UI visualizer just yet for the explain statement, but that's definitely something we want to try and improve on, especially as our query planner and therefore the explain statement along with it gets more complicated and supports more types. We definitely want to make that easier for users to understand. So yeah, we've got plans for that, and we've also got a request on our GitHub for slow query profiling, so being able to know which queries are running slowly and therefore which ones need to have work or which needs to be optimized from a development point of view. So those are definitely things we want to improve in the future and have on our roadmap. So got a question here from Carlos. Sorry, the text on my screen is very small. Great to have you here with us, Carlos. So is there a roadmap indicating when all these indexing related fixes improvements will land? It's actually something we're working on. We are working on a best practices document at the moment. We'll be releasing that very soon. That will tell you all about how you can improve the performance of your queries, how you can set up SurrealDB in the right way so that it optimizes and works for you in the best way possible. And along with that, we have kind of very detailed documentation on what index and index types and what index operators are supported right now, what we're working on, and what we're working on for the future. So definitely that best practices doc will be available and shared with you all on our documentation page and on a separate repository very soon. And yeah, that will answer that question in terms of the roadmap for these features. Zav, a good question. It's one we get a lot at the moment, and we're working along on that. So performance right now, with our next release, we're going to be putting out performance benchmarks. So that will compare us to Neo4j. It'll compare us to Postgres, other databases like MySQL, MongoDB. It also looks at our internal key value store, so our key value store called SurrealKV, and how that compares with other embedded engines like SQLite and LMDB and RocksDB and Fuel and ReDB and other Rust or C-based embedded key value stores. So that's definitely something that we'll be sharing soon. As I said, that best practices doc comes with that repository, so we'll be sharing that at the same time. Jason, yeah, geospatial indexing is going to be very useful for some of your customers' data. That's great to hear. I mean, I think GeoJSON and geospatial data in SurrealDB is something we don't talk about enough. It's an incredibly powerful feature, especially that you've got support for all the GeoJSON types as typical objects, and the ability to search the operators in your queries and how they work in terms of contains or within or near to, or if it crosses a polygon. It's very powerful functionality that we don't really talk about at all. So it's great to hear that you're using this functionality and it would be useful to your customers. Jump on our Discord, share your use case. That's always useful to us when we're building out new features and knowing which ones to prioritize. Also, if you've got requests or ideas on how features can be implemented or what would be useful to you, definitely submit a feature request on our GitHub issues.
The nice thing with geospatial is that when we work on vector search, we work with dimension, and in fact the algorithm that we're implementing could work as well for geospatial. So because in fact it's vectors of tree, right? Vector of dimension tree. So we will come up probably sooner than later with something. And there is also Delaunay calculation as well, because we want this to be efficient, right? So yeah, we have that in mind.
It's a great question, and this question here from Jason again, with regards to speech geospatial indexing, how are you planning to index multi-line or multi-polygon geometries? So in SurrealDB, and Emmanuel touched on this earlier, when we build a full text search index, we're actually building a B tree on top of our key value storage engine. And that enables us to offer exactly the same functionality for full text search, whether you're running on embedded, whether you're running on single node, or whether you're running in a distributed environment. So that B tree, the blocks of that B tree, or the pages of that B tree, effectively map to elements of the key value store. Now, this is very similar to how, as Emmanuel said, how the HNSW, how the M tree, and how, whether it's quad trees or any type of geospatial indexes that we might implement in the future, those are all done in the same way, or they will be implemented the same way. So we'll be building those trees and storing them in blocks on top of the key value store, which will enable that functionality, not just to work single node, but to work in whichever environment you are using SurrealDB in. So that's really important. Specifically to answer your question there, how we do multi-line or multi-polygon geometries, probably that depends on the implementation when we get to it. But as I say, this will be using the best techniques that are out there to index geospatial data, whether that is quad trees or whether that is other types of trees that are best suited to that type of GeoJSON data. And under the hood, as you know, these are all just collections of F64s or F32s. So that's come to the end of our questions. Thanks for those questions. It's really good to have kind of input from the community as we're building out SurrealDB and as we build out more functionality and see how users are using it. That's important to us. Emmanuel, where do we go from here? I think this has opened so many more questions about another stream in the future and what we should touch on. Anything we've missed?
I mean, yeah, everything that is upcoming. But we have a pretty fast path, iteration path, right? So there is a lot to come. So in the next months. I think distribution is part of the topic. Parallelism. So we have done a really amazing work recently in assessing the performances, and you will see soon, hopefully, some feedback about this. And we have a path for a lot of improvement there. So yeah, so I can just give rendezvous for few releases. Right.
Amazing. Well, look, we've got a lot planned. There are a lot of performance improvements and optimizations and new functionality coming in the next release 2.2, and we'll be sharing our best practice documentation, performance benchmarks, and in addition to that, the kind of roadmap around indexing support and index types and operator support very soon. So to those of you who are waiting, thank you for waiting. That's coming. We're definitely not forgotten about that. We're focusing on that very importantly internally in SurrealDB. Our next stream, I don't know the exact date, but that's going to be on graph and how you can leverage graph queries inside SurrealDB. We've had some amazing functionality added recently around arbitrary depth traversals, recursive traversals, and shortest path calculations. And we've got some amazing functionality that we're going to be sharing with you very soon as well. So can't wait to have you join us on the next stream, especially if you're interested in some of the graph functionalities of SurrealDB. Other than that, it's been great to have you here. Thank you for joining us, whether that's on LinkedIn, Twitter, or YouTube, or wherever you've signed in from today. Thank you, and look forward to seeing you on a future stream. Emmanuel, thank you to you too.
Okay.